Okay, so we're going to be working on multiplying and dividing rational expressions here. Now, what they want us to do in this question is to simplify and state any restrictions. Now, really, in order to do that, simplifying what they're talking about is essentially factoring everything. Okay. Now, in the top two numerators here, they've taken out a common factor. In fact, on the one on the right, we look in here, there's really no factoring I can do to make this simpler. This one here, I have a trinomial. Okay, so I might be able to factor that. It's a quadratic, and I think I can use some quadratic factoring to factor it. So, okay, we'll highlight this one in green to start. So I'm going to work on this one in green. I'm going to separate each part. So that part there, n squared minus 7n plus 12. Now I can't remember if you use decomposition for factoring or whatnot.
Yeah.
This one is a value is 1, so this is really easy. We just need two numbers that multiply to 12 and add to negative 7. Okay.
-3, -4.
That's right, -3 and -4. So our factor form is n minus 3 and times n minus 4. Perfect. So we can replace that with this. Okay. The next thing we're going to look is the denominator on this side. The denominator is another trinomial, and yellow is going to be hard to see that in, so we'll do it in purple. Okay. Same idea, n squared minus n minus 6. Okay. So again, same idea, two numbers that multiply -6 and add to -1. And we're left with n minus 3, n plus 2. Okay, so that's that in factor form, so that's simplified. And then the last one we want to factor here, a bluish color, n squared minus 4. Now this is a quadratic. Do you happen to know what type of factoring you use for this?
Big square?
Very close.
Yes.
Perfect square is a trinomial where we'll talk about that after. But this one is the difference of squares. And the difference of squares, we just square root the first and last term, and then one will be positive, one will be negative. So square root of n is n, square root of 4 is 2, and 1 is a plus, and 1 is a subtraction. Okay. So there, we can simplify all of those. So now we're going to rewrite our expression with our new simplified version. So our rational expression on top reads 2 times n minus 3, n minus 4. Right? The bottom is going to read n minus 3, n plus 2. Okay, divided by, and I'll put the division signs in a second. Top will still say the same. There's nothing we can do that has been simplified as far as possible. And the bottom will read n minus 2, n plus 2. Okay, we'll write our little fractions here. Okay. Now, we do have to carry out the division part to this. And think of this like we're dividing fractions, okay? And we know that when we have two fractions, whatever they are, and we're dividing, we just invert and multiply, right? Now, that's great, makes it simple, but because we have to state restrictions, that might get confusing at the end. So the first thing we want to do is state any restrictions on these guys here. Okay? And what we mean by restrictions is we can't divide by a value of 0. Okay, this is, if you put in a calculator, it's an arrow. This is almost an impossible number. We can't divide anything by nothing. So essentially, we got to make sure that neither of these brackets equal to 0. Because if one of them equals to 0, what's going to happen is when we multiply, the other will be equal to 0, and this fraction will be above 0, which is no good for us. So in order to do that, we can set each of the brackets equal to 0. All right, so we have n minus 2 equals 0, and n plus 2 equals 0. And really, it should actually say n minus 2 does not equal 0, n plus 2 does not equal 0, to find out our simplified version. When we move negative 2 over, n cannot equal positive 2, and n cannot equal negative 2. So that's two restrictions to start. Okay. Now we'll invert this, and we'll state our other restrictions. Okay. So when we flip this and multiply, still same idea. So we have 2 n minus 3 and minus 4. Lazy there. 3 n plus 2. Now we turn it into a multiplication question, and this is going to be inverted. We'll have n minus 2, n plus 2, divided by 5, n minus 4. Okay, same idea now. We need, I think I did this one in yellow. And we'll do this other one in a pink. Oops. Okay, we need to find the restrictions of those before we start to simplify further. Because we're going to be able to multiply these and then eliminate a lot of them to make this a simpler question. But we still have to state some more restrictions. So we already have 2. N can't be positive or negative 2. Let's state a couple others. N minus 3 can't equal 0. N plus 2 cannot equal 0. Therefore, n cannot equal 3. And n cannot equal negative 2. Yeah, we already have that one. Here, 5 times n minus 4 cannot equal 0. Well, we divide both sides by 5. We get n minus 4 cannot equal 0 because 0 divided by 5 is 0, which means n cannot equal positive 4. So now we've got all our restrictions. So we're not even done the question, but we have the restrictions. Restrictions are, and I'll write them down here in red. N cannot equal plus or minus 2. That's a simple way to kind of write it instead of writing it twice, right? Cannot equal 3 and cannot equal 4. Does that cover all our bases? Yeah, 1, 2, 3, 4, 5, but this is a duplicate to negative 2. Good. So there we go. Those are all the restrictions. Now, when you multiply fractions, we multiply the top by the top and the bottom by the bottom. But I'm not going to do anything distributive. Essentially, what I'm going to do is I'm just going to make this one large fraction. Okay. I'll also move our constant term kind of to the front. It'll help us see things a little better. So when we do that, we're going to get 2, n minus 3, n minus 4, n minus 2, n plus 2, whole lot of multiplying across the top here, divided by, I'm going to move the constant to the front, which is our 5, right, just so the constants are both at the front, and then n minus 3, excuse me, n plus 2, and n minus 4. Okay, now we can start to simplify, where any bracket that we have on the top and the bottom essentially can be divided to equal a 1, or they usually call it canceling out. So we have n minus 3 and n minus 3 can drop out of the equation, n plus 2 and n plus 2, and n minus 4 and n minus 4. Well, this leaves us with a much simpler question now. We can't eliminate the 2 and 5, they're just the way they are. So we have 2 times what's left, n minus 2, divided by 5, with all of those restrictions. So here's our simplified version, far simpler now, and we just have 4 different restrictions involved in this question. Okay? So quite a bit of work for one of these questions.